Good morning everyone. Myself is Parminder Kaur from Government Polytechnic College for Girls, Jalandhar. Today I am going to discuss with you on the topic partial fractions. Today we will discuss the two types of partial fractions. The first type of partial fraction when the denominator contains repeated linear factors, and the second type that we are going to discuss today is the when denominator contains non-repeated quadratic factors. Now, before starting the questions, we should know the concept what is fractions. What is fraction? Any expression of the form px over qx, where px and qx are polynomials is called a fraction. Is called a fraction. Now, there are two types of fractions. First type is your proper fraction. Proper fraction when the degree of numerator is less than the degree of denominator, then we say that the fraction is a proper fraction. The example of this is, for example, we can take x minus 1 over x square plus 5x plus 6. Now, in the denominator we have x minus 1, whereas in denominator we have the terms as x square plus 5x plus 6. Now, degree of numerator is 1, whereas the degree of denominator is 2. It means the degree of numerator is less than the degree of denominator. Therefore, this fraction is a proper fraction. Now, the second type of fraction is your improper fraction. Improper fraction when the degree of numerator is greater than or equal to degree of denominator, then we say that the given fraction is an improper fraction. Now, the examples of improper fractions are x square plus 3, x square plus 5x plus 6. Now, the degree of numerator is 2, the degree of denominator is also 2. This is the case of equality. Then this fraction is known as improper fraction. The another example of improper fraction is x cube plus 2 over x square plus 5x plus 6. Now, in this case, the degree of numerator is 3, whereas the degree of denominator is 2. It means the degree of numerator is greater than the degree of denominator. Therefore, this is your improper fraction. Now, the thing that we must keep in our mind before solving the questions is that the given fraction that we are to resolve should be proper fraction. If it is improper fraction, first we will change it into proper fraction. Now, the question arises how we change an improper fraction to a proper fraction. This we can do by the division. Write on the note, we must divide the numerator by denominator and express the given fraction as a quotient and a proper fraction. It means if in the question it is an improper fraction, in order to make an improper fraction to a proper fraction, what we will do? We will divide the numerator by denominator and write the given fraction as a quotient and a proper fraction. When we have the proper fraction, we can solve the question. Now, we know the definition of partial fraction. What is partial fraction? We have learned how to express two or more simple fractions connected by plus sign or minus sign into a single fraction by taking the LCM of the denominators. For example, we have two simple fractions 1 over x plus 3 and there is another fraction 1 over x plus 4. If we connect these two fractions with the plus sign, how we will solve it? We have already learned this. We do by taking the LCM. We take the LCM, LCM comes out to be x plus 3 into x plus 4. This is x plus 4 plus x plus 3, or we write this as 2x plus 7. This we get as x plus 3 over x plus 4. This you have already learned, that we have connected the two simple fractions into a single fraction, that is 2x plus 7 over x plus 3 into x plus 4. Now, what is a partial fraction? It is the converse. Partial fraction is the converse of process. What is converse process? That is to decompose or break up single fraction into a number of fractions having their denominators as the factors of the denominators of the denominators of the original fractions. Thus, what we have done previously, we have said when by taking the LCM, we made the two simple fractions into a single fraction. Now, partial fraction is this, we will have this compound fraction. We are to split this into two simple fraction. We can see here that 1 over x plus 3 and 1 over x plus 4 are the partial fractions of 2x plus 7 over x plus 3 into x plus 4. Now, we know that in order to find the questions of partial fraction, first we have to check that the given fraction is proper or improper. If it is proper, it is okay. If it is improper, then we change it into proper fraction by division. Then there are two types that we are going to discuss today. The first type, when the denominator contains repeated linear factors. For a repeated factor of the type ax plus b whole square, there corresponds two partial fractions of the form, the two partial fractions will be of the form a over ax plus b plus b over ax plus b whole square, where a and b are constants. B are constants. Now, if there is in the denominator, the factor we have the linear factor as ax plus b, it is being repeated how many times? 2 times. For resolving this into the partial fraction, we will have the fraction like this: a over ax plus b over ax plus b whole square, where a and b are constants. Similarly, for ax plus b cube, we will have how many partial fractions? 3. We will split it into 3. In the first denominator, it will be ax plus b. In the second, it will be ax plus b whole square, and in the third denominator, we will write ax plus b cube, and then we will take the LCM, and in order to find the values of the constants a and b, we will put ax plus b equal to 0. And for other constants, we will equate the coefficients of the terms from both sides. Now, let us do the first question. The first question is, resolve x square plus 1 over x plus 2 whole square into x minus 3 into partial fraction. Solution: the fraction we have is x square plus 1 upon x plus 2 whole square into x minus 3. First, we have to check whether the given fraction is proper or improper. It is proper fraction. Here, degree of numerator is less than the degree of denominator. Therefore, it is a proper fraction. Is a proper fraction. Now, let this fraction x square plus 1 upon x plus 2 whole square into x minus 3. In the denominator, we have the two factors. Both are linear. This is non-repeated factor. This factor is repeated how many times? 2 times. So, we will split this factor into two partial fractions, that we will write this as a over x plus 2 plus b over x plus 2 whole square plus c over x minus 3, and let us mark this equation as equation number 1. Now, the next step is we will multiply it, the both sides, multiplying both sides by x plus 2 whole square into x minus 3. What we get? On the left hand side we will get as x square plus 1. On the right hand side we have a will be multiplied by x plus 2 into x minus 3 plus b will be multiplied by x minus 3 and c by x plus 2 whole square. Let us take this equation as equation number 2. Now, in order to find the values of, question is we have to find the values of a, b and c. One value we can find by putting x is equal to minus 2. When we put x is equal to minus 2 here, we have minus 2 square plus 1. Minus 2 when we put here, this factor becomes 0. The whole product becomes 0. Here it is b minus 2 minus 3. When we put minus 2 here, minus 2 and plus 2 is 0. This is 0. We got that minus 1 is equal to minus 2 square, it is 4 plus 1. This we get as 4 plus 1 equal to minus, this we get as minus 5b, or value of b comes out to be minus 1. Now, to find the value of c, we put x is equal to 3, put x is equal to 3. On the left hand side, we have 3 square plus 1. When we put 3 here, this is 0, this total will become 0. When we put 3 here, this 3 minus 3 is 0, this total will be 0. 3 plus 2 is 5, 5 square into c. Now, 3 square is 9, 9 plus 1 is 10, 10 is equal to 5 square is 25 c, or we get the value of c as 10 over 25, or we can write the value of c as 2 over 5. Now, we know the value of b, we know the value of c, we have to find the value of a. This value we cannot find by simply substituting. Here we have to equate the coefficients. So, in order to equate the coefficients, first we solve this equation, equation number 2. We get the equation as x square, the equation 2 was x square plus 1, a x plus 2 x minus 3 plus b times x minus 3 plus c times x plus 2 whole square. This was our equation number 2. Now, we compare the coefficient of x square. Compare the coefficient of x square. On the left hand side, the coefficient of x square is 1. On the right hand side, when we multiply this x by x, we get x square, and the coefficient of x square is a. Here there is no coefficient of x square, and here when we open this bracket x plus 2 whole square, we will get this as x square plus 4x, and the coefficient, we are equating the coefficient of x square, it means the coefficient of x square is c. This is a plus c, or value of a will be 1 minus c. The value of C we know is 2 by 5. We know this how to solve. We take the LCM 5 minus 2, that is 3 by 5. It means the value of A is 3 by 5. Now, we know the value of A, we know the value of B and C. We substitute the values of A, B and C in equation number 1. Put the values in equation 1. We get the partial fraction of x square plus 1 over x plus 2 whole square into x minus 3 as A, value of A is 3 by 5, x plus 2, value of B comes out to be minus 1 over x plus 2 whole square, and whereas the value of C was 2 over 5, x minus 3. This is our answer. We know the value of A, B, C. Quickly we repeat what we have done. This was our partial fraction. Firstly, we found that is a proper fraction. Then we split these into two factors, x plus 2 and x plus 2 whole square. Third factor as such, C over x minus 3. In the next step, what we have done, after this we have multiplied by the x plus 2 whole square, x minus 3. After multiplying, in order to find the values of A, B and C, first put the value x is equal to minus 2, we get the value of B as minus 1. When we put x is equal to 3, we get the value of C as 2 by 5. And next step, we compared the coefficient of x square, and we got the value of A as 3 by 5. After finding all the values, we substitute these values in equation number 1 and we got the result. Now, let us do one more question. Write down the statement. Resolve x square upon x plus 1 cube into x minus 1 into partial fraction. Now, in the solution, the partial fraction, the fraction we have is x square upon x plus 1 cube into x minus 1. Now, this is a proper fraction because degree of numerator is 2 and the degree of denominator when we solve this is more than 2. It means it is a proper fraction. Now, we know this is a linear factor, it is not being repeated, but this factor is repeating how many times? It is being repeated how many times? It is being repeated for 3 times. So, we split this into 3. We write this as A over x minus 1, then B over x plus 1, C over x plus 1 whole square and D over x plus 1 cube. Let us mark this equation as equation number 1. Now, next step is we multiply by its LCM, multiplying by x minus 1 into x plus 1 cube. When we multiply, we get the equations as the left hand side as x square, right hand side as A into x plus 1 cube plus B. When we multiply this by x minus 1 into x plus 1 cube, we get this as x minus 1 into x plus 1 square, and C as x minus 1 into x plus 1, and the last as D into x minus 1. Let us take this equation as equation number 2. Now, in order to find the values of these constants A, B, C and D, We can put x is equal to 1, we will get the value of one constant. By putting x equal to minus 1, we will get the second value, and for other two values we are to equate the coefficients. To find A, we will put x equal to 1. When we put x is equal to 1, we have on the left hand side as 1 square. Let us check what was our equation. This was our equation. When we put x is equal to 1 here, we get here as 1 square. Here we will get as 1 plus 1, 2 cube, that is 8a. But when we put 1 here, this becomes 0. Put 1 here, this will become 0. We put here 1, this becomes 0. All other will be 0. So, we get as 1 square is equal to a 1 plus 1 cube. This is 2 cube, that is 8a is equal to 1, or value of a that comes out to be 1 over a. Now, to find d, put x is equal to minus 1. Left hand side we get as minus 1 square. Similarly, all other terms will become 0, only we will left with d into minus 1 minus 1. Now, minus 1 square is 1, minus 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 2d, and the value of d comes out to be minus 1 over 2. We know the value of a, we found the value of d. Now, we have to find the values of b and c. For that purpose, we solve the equation number 2. Solving equation 2. When we solve the equation 2, left hand side we have x square, a, it was x plus 1 cube. X plus 1 cube becomes x cube plus 3x square plus 3x plus 1 plus b, x minus 1 as such, and x plus 1 whole square as x square plus 1 plus 2x plus c. With c we have x plus 1 into x minus 1. We will apply the formula a plus b into a minus b, and that is a square minus b square, that is x square minus 1, and the d as such x minus 1. Or we say this as a x cube plus 3x square plus 3x plus 1. We solve these two brackets, we multiply by x, and then we multiply by minus 1, and we get this as x cube plus 2x square plus x minus x square minus 2x minus 1 plus c as such x square minus 1 and d as such x minus 1. Or now we connect these x square. We have x cube, the coefficient of x cube is a. Here the coefficient of x cube is b. It means the coefficient of x cube comes out to be a plus b. Now for x square, we multiply by this by 3, we get as 3a. From here 2x square minus x square, that is x square. It means the coefficient will be b. Here the coefficient of x square is c, and there is no term of d. It means this is our x square. Now combine the terms of x coefficient of x is 3a. Here when we solve the x values, this is x, this is minus 2x. When we solve this, this comes out to be minus x, and the coefficient will become minus b. There is no coefficient of x here, coefficient of x is d, and we write x outside, and now write the constant terms that are a. From here we get as minus b, here we have minus c, and here we have minus d. Now we are to compare the coefficients. Comparing coefficient of x cube, comparing coefficient of